All right, another problem here of time dependence, and this is a little bit more involved problem, okay, because there are many parts to this. In the first order reaction, and this is a decomposition of dinitrogen pentoxide at 335 Kelvin, and the reaction is given to us, which really for us it doesn't matter, because what's important to us is that this is first order, because that tells us which equation to use. So if we start with 2.5 grams of dinitrogen pentoxide and have 1.5 grams remaining after 109 seconds, so then the question is, what is the rate constant, K? What is the half-life? And then the third question is, what is the mass of N2O5 remaining after 5 minutes? Okay, so since this is a time dependence question and it's a first order decomposition, we need to find the equation first, okay, and our equation for a first order reaction is ln A after time t and A original, which is equal to minus KT. Okay, and so the first thing we are going to have to do is we're going to have to calculate for K, okay, in this. So let's get started then. So ln, now since we're not given molar, we're given grams, we'll just go ahead and use grams, okay, and since we have 1.50 grams left here, 2.50 grams over here to begin with, you see it doesn't matter because you're going to cancel out your units. So whether you start with molar or grams, it doesn't matter so long they're the same units, okay, and then minus K is what we are calculating for, and then the seconds are given to us, which is then 109 seconds. So then go ahead and take the natural log of 1.5 over 2.5, do the division first and then take the natural log, and your answer will come out to be 0.511, and that is a negative, okay, so make sure you keep that negative, minus K times 109 seconds, okay, and so though K is minus 0.511 divided by 109 seconds, and this becomes positive, which is then equal to 4.69 times 10 to the power of negative 3, and this is per second. So this is our value of K for first order, and you know it is also correct because K value for first order is always per second. Okay, you can see that in your table that I've given in the PowerPoints. All right, and then we're going to be calculating the half-life. Now this is a nice like rounded question, okay, it has everything in it, you know, from time concentrations to half-life, okay, everything. This is like a really good exam problem. So half-life is 0.693 divided by K, and so now 0.693 divided by 4.69 times 10 to the negative 3 per second, and so half-life is 148 seconds, okay, for us. So simple ones, you just need to know what equations to use, okay. So this is again for first order equation. And then the last question, what mass of dinitrogen pentoxide will remain after 5 minutes? So again we have to use this equation, okay, over here. So ln, and now we are looking for the concentration after 5 minutes, so which means the A we don't know, or N2O5 if you want to, we don't know that, but we know we started with 2.5 grams, and this is equal to negative 4.69 times 10 to the negative 3 per second times 5 minutes, so 5 times 60, okay, and then that is seconds for us. Then go ahead and do the calculation here, minus 1.41, and again take inverse log, or what I call anti-log, okay, and then you'll be taking the anti-log of inverse of ln, which means e to the power of negative 1.41, all right. That's what you need to do because the ln over here will cross itself out. So which means that the concentration that's left over divided by 2.5 is equal to 0.244. So concentration of A is 0.244 times 2.5 grams, which makes sense. It should be less than 2.5 grams, and it is 0.61 grams. Okay, so nice wholesome problem here, calculating everything for a first order reaction. Now if it was a second order reaction, you would just go ahead and use the second order equations. Okay, that's about it, but the problem solving is the same way.